Today I want to talk about the basic operations you can do on complex numbers. Let's take two complex numbers. z1 is x1 plus I y1 and z2 equals x2 plus I y2. And the basic operations we're going to discuss is plus, minus, multiplication of two complex numbers and division of two complex numbers. Yeah? So let's start with addition. z1 plus z2 equals x1 plus I y1 plus x2 plus I y2 equals x1 plus x2 plus I y1 plus y2. And what you can see is if you add complex numbers, you essentially add the real parts and you add the imaginary parts, like you do here. Yeah? So now let's subtract two complex numbers, c1 minus c2. We get x1 plus I y1 minus x2 plus I y2. And we can rewrite this as x1 minus x2. Yeah? Plus I y1 minus y2. And again, like in the previous case, you add essentially where you do addition when there's a sum, you do subtraction when there's a minus, so you subtract the two real parts and you subtract the two imaginary parts. Let's now do a multiplication of two complex numbers, z1 times z2. Yeah, so we write out c1, x1 plus I y1. We multiply that by x2 plus I y2. This gives you, working it out, x1 x2 plus I x1 y2 plus I x2 y1 plus I squared, which is minus 1, minus y1 y2, collecting the real and imaginary parts, x1 x2 minus y1 y2 plus I x1 y2 plus x2 y1. And you see that that's a little bit more complex. Yeah? Let's now try to divide two complex numbers and try to simplify that. z1 divided by c2 equals x1 plus I y1, x2 plus I y2. Now, in order to simplify this, we need the concept of complex conjugate. And the complex conjugate of z1, and you usually write that with a bar above, is x1 minus I y1. So the complex conjugate of a complex number, x plus iy, is x minus iy. So what we're going to do here is we're going to try to simplify by doing the following. iy1. We're going to multiply that by the complex conjugate of the bottom. So we multiply that with x2 minus iy2. And we do the same at the bottom. x2 plus iy2, x2 minus iy2. We can work this out. We get x1, x2, right? And we get plus I squared is minus 1, I1, I2 in this case, plus I. And we have x2, y1 minus x1, y2. And we divide that by its complex conjugate multiplied by the original, gives us x2 squared plus y2 squared. I squared is minus 1 times minus is plus, I2 squared, plus I y2 x2 minus I y2 x2. So that disappears. So you see that a real number turns up in the denominator. So now you can simplify this. And you can say, okay, z1 divided by c2 is now x1, x2 plus y1, y2 divided by x2 squared plus y2 squared. That's the real part of the division of two complex numbers. And the imaginary part, I, equals x2, y1 minus x1, y2 divided by x2 squared plus y2 squared. So you see that the division is quite a bit more complex. If you want to rewrite that into a new complex number, you see that it is quite complex when it comes to the relationship between the original one and the division. Okay? Now the last one I'm going to put in is calculating the norm, so the length of z1 for instance. And we can do that using the complex conjugate. So for instance, if you have z1, you want to calculate the length. By definition that is z1 times z1 complex conjugate and taking the square root. So let's work this out. That's the square root of z1 dot c1 complex conjugate, which is essentially x1 squared plus y1 squared. Yeah, so if you want to calculate the length of z1, you essentially multiply z1 by its complex conjugate and you take the square root. And that's how you get the length of z1. And you can see that as some sort of a vector, right? If you draw this in the complex plane, z1, right, with x here and iy here, and you have some sort of point z1 with x1 here and y1 here, the length of the vector is indeed, according to Pythagoras, x1 squared plus y1 squared. And that's what you see here, and the square root of that. Yeah? So I feel this is a good place to stop. If you like this video, please like and please subscribe, and I'll see you in the next one.